This is the key to worksheet 11.3 part 3, and this is a mixture. So that's a mixture of permutations and combinations. So you need to determine when you look at the problem whether it's going to be a combination or permutation problem. So remember, if you look at permutations, that's where the order matters. Okay, order matters. If you look at combinations, the order does not matter. Order does not matter. Okay, and the permutation formula, although you're not asked to use it, it's just asked to use the calculator. But just to remind you, the permutation formula is n factorial over n minus r factorial. And over here, the combination would be n factorial. It's the same thing as this one, except, you see numerator and denominator is the same thing, except in the denominator, there's an extra factor that's r factorial. Okay? All right, so in number 1 through 4, you just want to set it up and then use your calculator to come up with the answer. So, determine whether it's a permutation or combination problem. A corporation has 13 members on its board of directors. In how many different ways can it elect president, vice president, secretary, and treasurer? So the order matters here because you're selecting a president, then you're selecting a vice president, then you're selecting a secretary, and then you're selecting a treasurer. So order matters. Okay, so that's going to be a permutation problem. So you have permutation, you have 13 members, and you're choosing how many of them? So you're choosing a president, vice president, secretary, treasurer. So there are 4. So permutation of 13 items, taken 4 at a time. So you got 17,160. Number 2, in how many ways are there to select 3 bracelets from a box of 20? So you're selecting 3 bracelets. The order does not matter, right? So the order does not matter. All right, so that's a combination problem. So you say combination of 20 bracelets, choosing 3 at a time. So that's going to be 20, probability, combination, 3, and 1,140 ways in which that can happen. Okay, number 6, there are 6 women and 5 men interviewing for 4 cashier positions at Walmart. In how many ways can the 4 positions be filled? Okay, so you have 4 positions. Now keep in mind that these 4 positions, it's different than these positions, because these positions you are told is one's going to be a president, one's going to be a vice president, one's going to be a secretary, one's going to be a treasurer. So those were 4 totally different positions. Okay, so this is called president, this is called vice president, secretary, treasurer. So that's where the order matters. Here, these are cashier positions. All right, same position. It's just that you're choosing 4 people to fill that. All right, so the order does not matter here. Order does not matter. Okay, order does not matter here. So make sure you understand the difference between this and this. So this should help you a little with understanding that. So you see here, these are different positions: president, vice president, secretary, treasurer. Here, these are cashier positions. So same position. You're not told that one position's different than another, or better than another, or at a different level. Okay. So there's gonna be combination. So you have so all the one knows how many ways can the positions be filled. Okay. Well, you have 6 women, 5 men altogether. There are how many? 11. So that's going to be a combination of 11 people, and you're choosing 4 of them. So that's going to be combination problem 4 equal, so 330. So there are 330 ways to fill it. So if you were to list all these 11 people's names, and then just pick 4 at a time, you would have 330 ways. All right. Now remember, if those 4 people are picked in a different order in another time, it's the same list. Okay, so it would only be listed once because the order does not matter. In how many ways can the positions be filled if all women are hired? Okay, so all women are hired. So no men, right? So you're just looking at women. So there's only 6 women. So you're only going to say the combination of 6 women chosen 4 at a time, and that's it. Because no men are hired, right? It's just women. All right, so that's going to be that one. So it'll be 6 probability, and then combination 4 equal 15. So if you would take those 6 women's names and then choose 4, there will be 15 of them. 15 list. All right. So how many ways can the position be filled if 2 women and 2 men are hired? All right. So here let's look at the women first. So there are 6 women, and you're choosing how many of them? 2 times, and then there are 2 men. Oops, sorry. There are 5 men, and you're choosing how many of them? 2. So how many ways can that happen? So it's going to be combination. So 6 combination 2 times, and then 5 combination 2 equal 150. All right. So if you made a list, okay, and if you pick 2 from the 6 and then 2 from the 5, that list would include 150 list. Okay, number 4, a relay race has 4 runners who run different parts of the race. There are 18 students on your track team. In how many ways can your coach select students to complete the race? Now remember, keep in mind that there are different parts of the race, right? So the person that does the first part and the person that does the second part, those are unique positions, so to speak. So they're different positions. So the order in which you put runners in that different part does matter. All right. So the order matters here. So the order matters. So that's going to be a permutation problem. So that's going to be a permutation of 18 runners, and you're choosing 4 of them. So the person on the first part, the person on the second part, the person on the third part, the person on the fourth part, that's different. So for example, make sure you understand this. So let's say we name the people by numbers. So let's say person, by letters. Let's say person A, person B, person C, person D. All right, the first 4 people. All right, and let's say that the coach puts person A in position 1, person B in position 2, person C in position 3, person D in position 4. All right, or let's say the coach does this, puts person A in position 2, person B in position 1, person C in position 4, and then person D in position 3. See, those are different orders. That does matter. All right. See, these positions in which you put them does matter. Those 4 parts that we're talking about, the different parts of the race, that does matter. All right. So that's why it's a permutation problem. So you're going to say now 18 probability chosen 4 at a time, and there will be, so if you would list, now remember there are 18 people, right? I just chose the first 4 people, but you have 18. So you would have, if you did all of this, right here, you would have a list of 73,440. All right. Okay, so in this worksheet, there's a mixture. So you had to kind of understand when does order matter and when does order does not matter. All right, so that's the end of this worksheet.